Let us recap some of the RDBMS concepts before performing CRUD operations. We will develop programs to interact with the database using Postgres, which is RDBMS Database. RDBMS stands for Relational Database Management System. Tables will be normalized to ensure that records are uniquely identifiable, related with each other, etc. Almost all the transaction-based applications typically use RDBMS databases to persist the data in an efficient manner. Some applications are built on top of databases like MongoDB, DynamoDB, etc. But they are not meant for transaction-based applications. We typically use RDBMS for most of the transaction-based applications. Most of the database tables supporting transactional applications are in either third normal form or Boyce Codd normal form. To understand these terms, you should have some basic knowledge about normalization principles. I am not going to cover those details at this time, but I am just reiterating saying that the database tables supporting transactional applications should be in either third normal form or Boyce Codd normal form. In short, they are also known as 3NF or BCNF. When it comes to relationships between tables, these are some common relationships. We'll have one-to-one relationships, one-to-many relationship between the tables, many-to-one, many-to-many, etc. When we have many-to-many relationship, we typically implement using bridge tables, where the bridge table will have one-to-many to both the parent tables, and we will have some unique constraint on the columns which are related to those two tables in case of a bridge table when we have many-to-many relationship between two main tables. Tables typically contain different types of constraints. We'll have primary key constraints, unique key constraints, not null constraints, foreign key constraints referencing primary key constraints of its parent table, and more. Let's review some of the data models here so that you understand these terms up to an extent before we get into database programming to perform CRUD operations. This is an example for Oracle HR database. You can click on this link if this is not visible to you, and you should go to the actual data model which is provided by Oracle itself, and you can actually understand the relationships between the tables using the data model diagram itself. This is called as data model diagram. You can see that there are tables such as employees, jobs, job history, departments, locations, countries, regions, etc. If you look at these tables, you have departments and employees. Between departments and employees, there is one-to-many relationship. One-to-many. You can see the fork icon here, which means in a given department, there can be as many employees as they can be. That's why it is one-to-many relationship between departments and employees. Similarly, between jobs and employees, there is one-to-many relationship. You can see here. And also between locations and departments, there is one-to-many relationship. Like this, you have relationships defined between the tables. Now, if you go to the retail data model, you can see here, you can actually categorize these tables into transactional tables and master data tables. When it comes to orders and order items, they are kind of transactional tables. Whenever you try to purchase on an e-commerce platform, an order is placed, each order will contain order items, which means in each and every transaction, these two tables are typically touched. Whereas products, categories, and departments, they are not touched as frequently as orders and order items, because on a small e-commerce platform where there can be 100 to 150 products, you will not be updating your product catalog that often. They are pretty much static. That's why these are called as master data tables. Same is the case with customers. Customers might be 10,000 or 20,000 or 100,000 depending upon the scale of your e-commerce platform. Even customers' data doesn't change as much when it compared to transactional tables such as orders and order items. Now, when it comes to relationships between orders and order items, it is one-to-many. You can see one here and many here, the fork icon, which means for a given order, there can be as many items as they can be. Same is the case with customers and orders. With respect to products, we have one-to-many relationship between products and order items. If you try to understand the relationship between products and orders, it is many-to-many. One order can be placed with many products. Similarly, one product can be placed in many orders, which means we have many-to-many relationship. In this case, order items will serve as a bridge table between the two. And typically, if you enforce that within a given order, there can be only one product for a given product ID, then you can enforce the unique constraint between order ID and product ID. In some cases, we do that. In some cases, we don't. However, if you look at these, order item order ID is in red. Same is the case with order item product ID. However, order item order ID is the foreign key constraint to orders, whereas the order item product ID is the foreign key to products product ID. So you have two foreign keys, one for orders and another for products. So we have many-to-many relationship between products and orders. Order items will serve as a bridge table. Also, I'm reiterating saying that orders and order items are transactional tables, whereas products, categories, departments, as well as customers are nothing but master data tables. The data models will be like this, and you should be comfortable in interpreting the data models up to an extent before you go ahead and start developing the programs to interact with the databases. As we recap some of the basic concepts related to RDBMS, now it is time for us to start getting into the details with respect to performing CRUD operations using some of the tables in Postgres.